Hi, I'm Alan Ross, and I am the managing editor of APC Media, of all of our publications, and I am the moderator on this online tap changers, OLTCs. This power panel is sponsored by Maschinenfabrik Reinhausen or Reinhausen US, and you'll hear a little bit more about that in a minute. And then, of course, North American Substation Services. So, with that, let's introduce you to our panelists. Bob Very. Hey, Bob, you and I have been doing this a lot lately, haven't we? I mean, we
Yeah, we
did it
have.
in Atlanta. Yeah. But, Bob, if you talk a little bit about your background and career.
Sure. So I'm a 34-year industry veteran. Worked for 28 years at ABB in local roles in the US, regional roles across North America, as well as global positions within the company. Spent 3 years at Duke Energy, responsible for all large customer engagement, both on the commercial as well as on the regulated side of the business, and then joined Reinhausen about 2 years ago as the president and CEO of the North American or the US operations for the business.
Excellent. Thank you so much. There's the company info. You'll hear more about Reinhausen US at the end of this. So our next panelist is Shane Oakley. Shane came to us from North American Substation Services. I don't know if they use that anymore or just everybody says NASS now. What is it, the one correct?
Yeah, I mean, we essentially go by NASS, the acronym,
Okay.
but the full legal name is North American Substation Services.
All right. Go ahead and talk to us about your role in the industry. How'd you get into it and why? That's a good question.
Um, yeah, that's a good question. So, yeah, I'll be brief as I can here, but I originally started out my career in academia. I was a professor of mathematics and logic prior to coming to the power industry. My experience with the power industry was ultimately through my family. My dad used to work for Duke Energy, then Progress Energy, then Duke Energy again. Um, so when I was a kid, back before the current safety standards we have now, I would be dropped off at a substation, run around as a toddler, and play around and whatnot. So I kind of grew up in the vicinity of the power industry my whole life. And then for various reasons, I made a decision about 15 years ago to transition over to the industry. So I've been working with NASS since then, essentially specialize in initially high voltage testing, breakers and transformers, and then also assembly, oil processing, SF6 processing, and stuff like that.
Yeah. We'll hear more about NASS at the end. You can read this, and we'll hear more about them. Funny thing, you say you were a toddler. I have a toddler grandchild, and I cannot imagine putting her in a substation and letting her do what they do, which is touch everything. But
Yeah.
anyway, Shane, I'm glad you didn't touch everything, or you did, and you had enough shock to make your brain work. Our next person up here is from Doble. Doble is always a great contributor to these power panels. Lance Lewand. Lance, tell us a little bit about your background.
Well, my road to the electric industry is kind of strange. I got my degree in marine biology, and I lived in the Caribbean working as a marine biologist for about 3 years. And then when the money ran out, I had to find another career, and so this was it. So I started in Baltimore as in a service company that worked on transformers, and I ran a little lab there. And I convinced Doble to hire me back in '92, which took some convincing, but I finally did. And now so about 39 years in the industry, and I belong to ASTM, IEEE, Gray, a whole bunch of different roles. But right now I'm the R&D and technical director for all the Doble laboratories.
Excellent. And here's a little bit about Doble. So we'll the two sponsors will talk at the end of this a little bit, and most of you know Doble. So let's get started. Thank you for doing it, gentlemen. The beautiful thing about these power panels, they're not just a webinar. We call them power panels because that's a nice thing because of what we know as a power panel. But the other idea is that we want to bring subject matter experts together to talk about one subject and really nail down on it. You guys all, and I recognize this from our discussions earlier, you all bring something different to the marketplace. So I'm just going to ask that you raise your two fingers for that thing where you want to break in and ask a question of somebody else, or you have something else to share. Other than that, I'll try to stay out of the way. Bob, you're going to get the first question, okay?
Excellent.
And I thought about this because I've already interviewed you at Distributech and at TechCon, and I asked you the same question. I don't know if you're going to give the same answer. So here's the question again. We've seen a ton of change in this industry. It's just in the last, 5 years, because I've been in the industry about 20, 25 years now, and I've been in it just tangentially. But it was pretty much steady state until now. It is not steady state anymore. But when you think about where the industry is going, just the whole industry in general, what are some of the significant challenges or changes, or however you want to approach it, that you think we're going to have to deal with in the future?
Yeah, so I'll probably change my answer a little bit from the past conversations that we've had, only because I've had a little bit more time to think about it.
Okay.
So I'll bucket this into three areas, and one is demand, one is data, and one is decision making. I think those are three major challenges that customers in the industry are working through, as well as suppliers. So on the demand side, we're seeing, I'm not going to say unprecedented demand, because obviously when the industry was first growing back in the 30s, 40s, 50s, there was a lot of demand for technology and product. But over the past several years, we've seen a tremendous amount of demand driven by grid modernization, driven by aging asset replacement, and more so recently driven by data center demand, especially associated with AI, as well as the integration of renewables. So if you think about all that is driving a significant amount of demand for product in our industry. So that's something that suppliers, across, whether it be transformers, circuit breakers, switchgear, whatever, they're all struggling to meet that demand that we see in the marketplace. When we look at data, there's always been data available in the utility industry, but as we've seen a conversion to digitalization, there's so much more data that customers have to work through and try to understand. And in addition, they've got challenges with cybersecurity and how to manage the data protection side of things, and also data ownership. So I think data is a big area that creates its own challenges for the industry. And then the third, related to decision making, is what do you do with all that data? So you've got a tremendous amount of data coming in. You've got an aging workforce where a lot of the expertise has either retired or is going to retire in the next 10 years or less. So what do you do to make decisions on that data that you're receiving, and how do you use that in a useful way? So I'd say these are three of some of the major challenges that the industry is seeing today.
See, that is the same answer that you gave at Distributech, but different. The point was, underneath all of that, you had a lot of things that we're all looking at right now: data center demand, grid modernization, the digitalization. But the 3Ds, in fact, I'm going to steal that because I love that. I'm going to do something about the 3Ds of the future in the power industry. You will see it again, I promise you.
That was intentional.
That's good. So let's talk about that a little bit. Lance, what are your thoughts about what you've just heard? Anything to add?
Yes, absolutely. So I echo Bob's comments on data center growth, and even though the current president wants to have oil and gas, electric vehicles are going to be coming in the future, and they're going to place a lot of demand on the current infrastructure, and we just don't have it. I was up in NIPA 6 months ago, and they said they would not be able to meet that demand as it stands right now. So also the AI takes up a lot more power as well. What I see also is there's not enough large power transformer manufacturer in the US. It has left, but I think it's really needed here in the US in order to meet the ongoing demand. I also see battery storage as becoming a very integral part of the growing demand and able to stabilize the systems that we have. Um, and renewable energy, of course, is always on the landscape here. But there are challenges with renewable energy in that the transformers there need to be more robust. We're starting to see a lot of issues with bushing failures in renewable situations. Um, and reverse power flow and renewable energy is an issue that needs to be dealt with in a better way. The other thing is, I think as we look at demand, we have to look outside of our country too, especially wealthy countries. I think it's incumbent upon us to help electrify third world countries or areas that need electrification through solar or wind is probably the best two options at this point. So I think there's a humanity issue there as well in order to electrify those areas for people of the world.
Humanity, I like that. So we're now doing something for humanity. We barely can handle our own thing, and we're going to do it for you.
That's true.
You said outside of this country, we are primarily a United States media company. However, we have a large growing sector in Europe. Any thoughts specifically about that?
Yeah, I think well, there's a lot of large manufacturing of power transformers in Europe, so I think they're in a better place than we are here. Most of our transformers are either coming from Europe or South America or from Asia. So I think bringing that large manufacturing back, if we can, uh, will be good. I mean, the increase in electrical demand is only going to grow. The data centers are um, really testing the limits of our system at this point in time, and they're going up like crazy all over the United States. So I think in order to fill those needs, we might have to bring some of that manufacturing back.
Okay, okay, good thought. Go ahead, Bob.
I was just going to say, I mean, you bring up the point about demand, and it really is incredibly unprecedented to look at the globalization of the supply chain and how much more is coming in from outside the U.S. versus within the U.S. We see a lot of volume coming in from Asian countries like Korea, Taiwan, Thailand, China, but significant amounts coming in from Europe and South America, Mexico being one of the largest suppliers to the U.S. market. So you've got all the dynamics that are taking place with the supply chain that create its own challenges, especially when you look at suppliers that aren't necessarily familiar with the US standards and they have to adapt to it and they need to figure out how to adapt technology that's commonplace. For example, bolt-on reactive type tap changers is one example that becomes something that they haven't worked with in the past. So the ability to ensure that suppliers around the globe are also able to meet the requirements of local customers has been a tremendous challenge as we've seen that growth. I think the other thing you brought up, Lance, on data centers, every time you see a forecast from IEA, the growth numbers for data centers goes up like 50%. Maybe that's a bit of an exaggeration, but the fact is, every time we see a forecast, the forecast changes, and it always changes upwards. So, as we look forward, if that continues to head down that path, as suppliers of both transformers, and then you look at us as a supplier of tap changers, we also have to be able to grow to meet that demand because it is a significant driver for the amount of volume of product going into different substations around the country.
Okay, good. Shane, I didn't mean to leave you out, but because now you have the whole thing
No,
framed, and you can
no,
take a crack at it.
I agree with everything that's been said up to this point. I'll come to it from a different perspective though. To go back to the demand point, so we're a service company. We install transformers and commission them and whatnot. And the biggest thing I've seen from my point of view, at least, it correlates with what's been said is, you know, the demand on the global manufacturers is so significant now that, you know, we're really starting to see the effects of the pressure on them to produce the units. And I will say, you know, across the board, I'm not massive quality issues, but, you know, we're starting to see more quality issues on product coming out based on the, you know, significant pressure that's being put on these companies to pump out units for one. And I think it correlates with one of the largest problems I see, and Bob hinted at this as well, was the you know, we have a workforce that, like Bob said, you know, that the level of experience is diminishing day by day as more and more people retire, you know. And you know, the void, that the number of people that are retiring and lack of experience there versus the replacement for that experience is not caught up, I would say, across the board, expertise wise, manufacturing, you know, field service, anything for that matter. So that's one of the biggest, you know, challenges I see as well, is not just the product itself, but also the manpower, or human power, I should say, to actually produce a quality product and can keep the grid running.
Okay.
And generation, I think, is another big challenge. That's like we mentioned, is that there's the amount of power that's being consumed by these data centers is incredible. You know, you have entire nuclear power plants, for example, that are, you know, they're dedicated to servicing data centers essentially. So
I think that's why Microsoft tried to buy and regenerate one of the 3 Mile Island things for a data center up there. I don't know where that's going, but it's kind of a unique. If you'd have said that to me 5 years ago, I'd say you're crazy. I said, we're going to move because we started up big, and you guys keep getting to right where we want to talk about. We want to talk about OLTCs, but in between that and the big macro are transformers, right? So, Lance, I want you to take a shot at it. When you think about transformers in general, and you think about OLTCs, given all of the changes that you all just said there, what are the effects on and the changes that are taking place with online tap changers? All of those things that might negatively impact the flow in, the modernization, because I know power quality issues from distributed energy are greater than they've ever been. Does that impact OLT? So let's get down a little bit more granularly and talk about tap changers. What are some of the challenges that we're facing on that? So we give you the first crack at this, Lance.
Okay, sounds good. So at a recent Doble conference, design life of transformers is 20 to 25 years based on 100% loading. What we're finding out from utilities, they are expecting now 50 to 75 years out of their transformers. And with that is associated LTCs, obviously, and they're a critical component. And so they have to last a lot longer than what really they were designed for. And so if they fail, there's also collateral damage that can ensue and take out the transformer. So we want to make sure that doesn't happen. So, back in the early 90s, a gentleman named Rick Youngblood from Synergy, which is now part of Duke, was able to determine that a DGA analysis can provide exceptional information in that regard. And so we look at the gases both in break-in oil and vacuum tap changers. We look at the gases a little bit differently, but it has become a very, very good surveillance tool. And so if there's anybody out there that's not using it yet, I would really encourage them to use that. And the other issue that we're facing now is silver corrosion on tap changer contacts, whether that tap changer be on the outside of the transformer or integrated into the main tank. And we've had a number of failures in the past year and a half or so that are showing signs of the silver corrosion, whether it be in mineral oil or ester liquids. So those are things that I think people should be aware of and testing for in order to make sure that that tap changer is operating correctly. I can't speak to the technology or the mechanics of tap changers. I can only, as a laboratory nerd, basically, I can only look at the testing that's involved in trying to ascertain the condition. I think it's incumbent upon the people to be very vigilant on their testing programs in order to make sure that that tap changer is operating properly. And so that
Same,
those would be my comments.
same is true on transformers. I mean, the more
Yeah.
that you test, and that's why the whole, we're going to talk about that a little bit, because Bob's chomping at the bit because he knows some things that I know that he knows, but maybe you don't know that he knows. Shane, talk a little bit about what you've just heard Lance say. Are there any other things, or would you like to
Yeah, I mean,
elaborate?
I would say, going along with Lance there, I mean, testing wise, the DGA is definitely critical. I know we're going to talk about online monitoring here shortly, probably, stuff like that. That's for DGA in particular, for tap changers, something I've seen, that seems to help, as far as, predictive diagnostically determining, the health of a tap changer. But also, one thing I've noticed, and I think is a good thing, is a lot of utilities that have, in particular, what I can call arcing type, arcing and oil type tap changers. They're starting to either refurbish those, by, going in and basically doing a complete rebuild of the arcing type unit, or the even better solution, in my opinion, personally, is replacing those with vacuum type tap changers. Either, you can do a full wholesale replacement, which is, pretty substantial, change, taking a tap changer off and putting a new one on, or there are some versions where different types where you can actually basically it's just slot in and out. You slot a new vacuum type tap changer in there, and, you know, extending the life of a transformer. That's certainly a strategy to do that. It'll definitely increase, all things being equal, with the tap or transformer itself, extend its life. That's one thing I see as a benefit to the industry, to get extra life out of transformers, and
Right.
perhaps, you know, quell some of that, or buffer some of that demand on them moving forward. But
I think I was at a conference recently, and a Muni there. The city council told the Muni that they should give the plan to them for their transformers to last 75 years. You think about, and these transformers were in their 50s. They were 50 to 55 years old. And they hadn't been taking care of them for 50 to 55 years, and now they're going to try to get them to go to 75 years. What does that do to the tap changer that's on there? So Bob, you heard all that, and tap changers, and because your life is tap changers, right? You wake up and you think tap changers. Talk a little bit about what you just heard Shane and Lance say.
Well, maybe I'll take a step back, right? Because you're talking about the impact of tap changers and the transformer industry. I think let's kind of think about it when we initially talked about demand, as the demand is also having an impact on the overall supply chain. So, when you see a significant increase in the amount of transformers that are being installed in the US, whether it's produced in the US or produced by manufacturers outside the US, that demand has put a strain on the supply chain overall. So, one of the things that you see now is, in some cases, extending lead times for tap changers, and that creates some challenges for the OEMs and how they manage that. I know in Reinhausen, we've had lead times for our in-tanks, as an example, extend out quite significantly. So what that brings back then is an investment in capital in order to increase capacity in the US, in Germany, in China, elsewhere, in order to meet that demand. So I think that's really one thing that's happening across the value chain for transformers, is how do you ensure that you have the material you need to build a product? And that's one of the things we're focused on heavily as a company, to ensure that supply chain continues in a way that our customers, our OEM customers, are able to meet their customers' expectations. So that's one. Shane brought up a point about retrofit. So as customers look at their existing assets and say they've got an existing oil type tap changer that has had many operations and needs to be replaced, the option is always, do we replace the transformer or can we do something with the tap changer? And Shane brought up a good point that retrofit is a great option. And we have drop-in retrofit replacements for UTT and UVT tap changers. We've been providing those to the industry for many years and continue to do that. We can actually go out on older bolt-on tap changers, go out and completely replace them, and not only replace them with the latest technology, but also replace them with the digital part of it, which we really haven't got into. So I don't want to talk about digital yet until we get into maybe the next series of questions, but that's always an opportunity. And when we think about knowledge preservation, one of the things that we've invested in is what we call our Trafotech Training Center, which allows us to bring our customers in and where they want to maintain and ensure that their transformers last for a long time, especially related to tap changers. We're able to bring them into our training center in Humboldt and provide the training they need to be able to operate and successfully manage their fleet of tap changers for the long term. So it allows them to create that knowledge preservation that might be lacking because of retirements and those type of things. The other thing that's really happening on the tap changer side is we're starting to see a migration from big to small. And so you and I talked a little bit about the move to distribution. And one of the things that Reinhausen is really focused on is extending our portfolio down to the distribution side so that we can regulate on-load regulation of transformers down at the end of the distribution circuit as an example. So where customers are being impacted by solar arrays that are installed behind the meter, EV, which Lance talked about earlier, and all the impacts, not only of demand, but also the impact on voltage and either voltage drops or voltage surges in the network. These tap changers that are being installed on the distribution side are able to provide customers the ability to regulate down circuit to ensure that they don't have any voltage stability issues down at the end of the distribution circuit. So these are some of the things that are obviously happening overall. And then if you go back to DGA, I mean, DGA has been a big part of it, but there's much more that you can look at when you look at tap changers. You can look at vibroacoustic monitoring, which is more like a thumbprint that allows you to see what the initial condition is of a tap changer. And if you see changes over time, then that vibroacoustic monitoring will allow you to make decisions based on things going out of that initial thumbprint, so that you can actually take data from the tap changers and make decisions on how to go forward with repairs when you combine that with data coming out of DGA or other areas that you have within your tap changers.
Excellent. Yeah, go ahead, Lance.
Yeah, so Bob had mentioned a number of things. Especially supply chain. So, during COVID, even the test equipment that that Doble makes to test LTCs, we had supply chain issues there as well. So securing that supply chain and making sure that you can produce whatever you're producing, whether it's a piece of equipment or a piece of test apparatus, is really something that our purchasing department, our engineering department is always looking at to make sure that we can provide the customer with the equipment they need to do the testing. So supply chain has become a really big something we look at very closely within our company, and I'm sure most companies do at this point in time as well.
All right, let's move. We have a couple of questions that I think would be good one of them at least would be good to answer right now. And this first one's going to go directly to you, Shane. In the laboratory, right, you're talking about DGA. And the question is, why do you think it's important to monitor DGA in an on-load tap changer? And I think what's funny is I think all of the answers we've given so far is why you should do it. But let's you summarize that. Why should you why do DGA on OLTCs?
Actually, I'm going to defer to Lance on this one because Lance is our DGA expert here, to be honest with you.
So I can answer that. So as the contacts heat up, they tend to produce polymeric films on the surfaces of the contacts. And through the arcing, those films can get thicker and thicker. And as a result, what you do, you start to produce heating gases. And the gas we look at especially is ethylene, as opposed to in transformers where you're always worried about acetylene. But
Yeah.
in brake and oil temp changers, we're really looking close at the ethylene because that will tell you the carbonaceous films that are being produced that eventually can compromise the metal, can especially in the reversing switches. We see a lot of metal that becomes compromised. It can actually become welded together. It can break. And so it really tells you about the condition of the contacts that are occurring. And there's other tests that we can do besides DGA that tell us about the condition of the LTC. We do a metals test. We do some oil quality tests. The metals themselves will tell us about if we look for tungsten or copper or silver and how they're trending, or even silica, which is from fiberglass materials. If we start to see that material start to become more in the oil, then we know it's degrading from something within a tap changer. So there's a variety of analytical tests that we can use to determine if the components are in a good condition or if they're breaking down. So for ethylene, for brake and oil tap changers, that's the primary gas that we look at.
Okay. Bob, go ahead. Sorry, Shane, go ahead.
I'm sorry. I would add to, aside from the DGA itself, you can also monitor oil quality in terms of relative saturation of moisture and ppm there, and that's moisture in an LTC. It's various styles of them can be a slow killer over time. So if you can pick that up as well online, that's something that's beneficial, I'll say.
Okay, good. So Bob, do you want to finish what they're talking about? Because I have another question
I mean,
for you.
I am definitely not a DGA expert by any means. I mean, I think that's a useful tool in analyzing the condition of the oil within the tap changers. Likewise for transformers. I mentioned about vibroacoustic, but there's many other things that you can monitor on an OLTC to ensure that it's operating properly. If you're looking at motor current as an example, if you see issues associated with there, it might show that there may be some signs of distress within the tap changer. So there's a lot of different aspects of the tap changer you can monitor. And the product that we're building today in Reinhausen, both in Germany and in the US, as well as China, has the ability to monitor that on a real-time basis out of the box, as an example. So we haven't really got into the discussion of our ETO system, but that allows you to have that information at your fingertips from the time that you install it at the transformer OEM and then get it into the field for the customers. So whether you choose to put in a DGA, whether you choose to put on vibroacoustic monitoring, you want to advance to look at the motor current and those type of things. That data is all available for you to look at to ensure that you're getting real-time information on the condition of the tap changer, and you can make good decisions on what to do next.
Yeah. It's interesting you mentioned vibroacoustic. In the world of reliability and maintenance in the mechanical side of the world, not the electric side of the world, vibration analysis has been the go-to source for motors and anything that rotates. Well,
Yep.
The only thing that moves inside of a transformer other than the electrons is all of the contacts that are on the LTC. So it acts
Right.
more like a motor would. So the idea that you're talking about vibroacoustics there, they've been being used for a long time, maybe not to the extent you're talking about. So we're going to move into this next one. There's been technology changes, right? There's growth in technology changes, and that has not been missed on tap changers. So talk a little bit, Bob. We'll start with you. We now have predictive diagnostics. We've got online diagnostics. We've got so many different ways of approaching the ability to see whether something is going to fail prior to failure. Because is it not true that the second most important reason for transformer failures, bushings being number one, isn't it online tap changers, unload tap changers number two? The paper degradation is over time, but I think
Sure.
IEEE says these are the two main failure modes that are. So if you can avoid them, it's hard to avoid bushing failures because you can't get bushings either. And then retrofitting a bushing is time consuming, as I'm sure you know, Shane, what they have to do out there in the field. But what are the technology changes that have allowed us now to move to some of the same things that we've done on the transformer with online predictive analysis, making it so that we take that data decision maker and letting the system itself, I'm not going to say make the decision, but recommend, you've got cancer, this is what we recommend. You ultimately have to make the decision, Mr. Customer. Talk a little bit about that, because I know you've been going through a lot of the technology advances in load tap changers at Reinhausen. So, Bob?
Yeah, it goes back to gave you the 3 Ds at the beginning, and the 2 and 3 were data and decision making. And so we started over 10 years ago looking at how we can provide more value to our customers beyond just supplying a tap changer that operates reliably and predictably every time. We wanted to provide real-time data to our customers that allows them to look at the different sources of potential failure on tap changers, but also transformers, bring that data into a single industrial PC and analyze the data and then make recommendations on what to do next. So, of course, when we started that, it started with the tap changer itself, initially with the in-tank tap changers, and now recently we've launched that into the market and for the bolt-on tap changers. And this is our ETOS, or Embedded Transformer Operating System. So we take data, as I mentioned before, from just looking at tap position, number of operations, looking at motor current on the tap changer, looking at the vibroacoustic thumbprint, and then we can take data from DGA also on the tap changer as well as the transformer, cooling control, cooling monitoring, temperature monitoring, looking at the windings of the transformer, bushing monitoring. All this different information can come into a single industrial PC that's set up with building blocks that allows us to, depending on how much monitoring a customer wants to do, we can expand that over time or upfront, depending on how they want to do it, to provide data and then decision making on that data. So in essence, all the information that we have coming into ETOS allows us to provide a digital twin that we can analyze the condition of the transformer or the tap changer, and then make recommendations on what to do next. So, if there's a problem with the motor, what do you do next? If there's a problem on the bushing, what do you do next? And that's what ETOS is basically built on, and that's the principle of how we put this together. So in essence, we've gone from just providing the product that does that switching operation as you need to tap up or tap down, to a complete intelligent solution that provides data for customers to utilize and make decisions, because they're losing that talent to retirement. In order to preserve that knowledge of the condition of the transformers and how to assess it, it's now being embedded more into a industrial PC that has AI capabilities built in.
Okay. Comments, gentlemen, on what you've just heard Bob say. Start with you, Shane.
I must confess I'm not familiar myself with. I've heard of the ethos system. I've not had the experience of dealing with it. But I do think, generally speaking, that is the direction we do need to move into, as far as like we mentioned before, the retirement of experience in the industry, and ways in which to better track data and potential failure modes in particular, and what to do about them, right? And since we're specifically talking about OLTCs, it's the various monitoring that we can do on those in particular. But as far as the ethos system, it sounds interesting. I would like to learn much more about it myself.
That's why Bob said what he said.
Yeah. Well, I will say the beauty of ETOS is that it does allow you to both install it on a new transformer OLTC out of the box, but it's also something you can utilize for retrofit. So as customers want to look at having more data come from different sources on the transformer and the OLTC, you can actually go out and retrofit an existing fleet of transformers with ETOS as well. So I think companies like NASS with Shane, that ability to do that now is there. And so it's just a matter of, looking at the ecosystem of partners in the marketplace and how do you actually provide more of that data to customers and utilize the existing assets in the field and get more data out of them as well. So that ability to retrofit is also the beauty of the design.
Excellent. So go ahead, Lance. You got something to add to that?
Yeah, so like Bob said, they have a condition monitoring product, and I think a lot of companies are have that as well. I mean, Doble has Doble Prime, which does condition monitoring of tap changers and transformers and bushings and things like that. So I think those are important things to do, especially for a vacuum tap. The DGA monitor is a great tool because it doesn't produce a lot of carbon, and the oil's relatively clean, so it doesn't gum up the works in the DGA sensor. For break-in oil LTC, it's a little bit more complicated because those byproducts from the degradation of the oil and the material can cause some issues with pumping that oil into a DGA sensor or plugging up some stuff, but there are ways around it. And I know that a lot of utilities are starting to put sensors and actually filtering units on break-in oil LTCs in order to reduce the carbon loading and remove contaminating particles out of the oil that are extremely beneficial and really can extend the life of break-in oil LTCs.
Okay. Shane, you got something to add?
I did have a question for Lance on that. I've been thinking about this myself as far as the filtration system. So, on the break-in oil tap changers, we do install quite a bit of various filtration systems, moisture wicking, particulate, filtering. I guess my question really is as far as those go, does that dilute or mess up potential diagnostic findings from DGA that we could?
It can change it slightly. So, for example, CO2 is affected. So, but you really don't use it as a diagnostic gas in LTCs. The ethylene and the acetylene are really your two primary gases. And so the filtering unit, and it depends on the type of filter it is. So when people are installing this, they should contact the manufacturer to know how the gases will be affected. And most of the companies that make the filters for these filtering units are aware of how it's affecting the gas profile. Like I said, the only gas that we've seen really to be an issue is CO2. But again, with different filter media coming out all the time, it's a good thing to check to see how it will affect the gassing pattern.
Okay. There's a number of questions that relate directly to what Bob was saying. So Bob, I'm going to get those at the end, but I want to insert a question right here, and you're going to go first on this one, Shane. It is, what are the predictive diagnostics and how can they prevent costly failures? And do you have any use cases when you look at a predictive diagnostic that said this came in, you saved the transformer? I'm adding that last bit in there.
It's hard to say if you've actually saved the transformer if it doesn't fail, but we've had multiple cases. I did one just to tie this into newer, not newer technology, but technology that is kind of newly being utilized heavily. One preventative maintenance test that we've been using is the dynamic resistance test, coupled with measuring the motor current at the same time and overlaying the graphs of the motor current with the dynamic resistance results going through the taps on the tap changer. We've had several cases with tap changers specifically where we've found contact erosion and misalignments that otherwise would not have been detected through other tests, and we were able to either replace contacts or realign the mechanism on the tap changer appropriately. Now, did it save the transformer? Possibly, right, or possibly save the tap changer. But it definitely detected a problem that we, otherwise would not have known. But generally speaking, we do preventative maintenance and find various things, try to correct them. And I think online diagnostics, we're mainly after the fact, so we're not actually actively involved in the monitoring itself per se. We get results from monitoring. I've definitely seen DGA monitoring results that have caused someone to shut off a transformer or for various reasons that definitely saved the life of the transformer. Would have been catastrophic failure. So.
And Lance or Bob, do you have anything to add about predictive analytics?
I can add
Yeah.
one case where we had a situation where we had a loose component within a tap changer. Excuse me, I'm sorry. And so with the vibroacoustic monitoring, because you saw that thumbprint go out of the range where it should be, you immediately recognized that there was something that was mechanically incorrect within the tap changer. And we utilized that data then to open up the tap changer, go in and obviously correct the situation that was there and put the tap changer back in service. So I would say in that case, would it have led to failure? It's certainly possible. But actually knowing that information and knowing that you had a situation that you needed to address and address immediately coming out of that online diagnostics is an important part of why you do it. It gives you data that otherwise you would not necessarily have had. And so, in this particular case that I'm mentioning, it did actually allow us to go in and quickly resolve an issue. And I'm sure Lance could talk a lot more about cases related to DGA.
He's about to, Lance.
I know he is.
Yeah.
I know he is. I cut him off. Sorry, Lance.
That's quite all right. So I can actually quantify some of that. So we probably have about 20, 25 LTC saves a year. So whether it's going to take out the transformer or not, you don't know. But if you're just saving the LTC, that's more than makes up for the cost of the testing, obviously. Just like transformers, you want to look at trends and rates, rate of gassing over time, rate of metal increasing over time. And so that type of predictive diagnostics is really, really important to do. And it does have a very good payback in the end, where you say to a person, listen, you need to go in, you need to either lock it out or take it offline. And the other idea about a program that our lab or any other lab does is to make sure that when you go into the LTC that you actually find something, because it would be pretty bad if you're opening up every LTC just because there's a little bit of gassing, and there's going to be gassing because the LTC operates by creating an arc, so you are going to have some gassing. It's just knowing what to look for and when to tell a person to go into it. So I think in terms of oil quality test and DGA test, DGA is by far and away the most important test you can do. Some other oil quality tests add to that, but if you're not doing it, I would really encourage you to do it. So that would be my comment in that regard.
Okay. Some of these questions, because we've got a lot of them and we're not going to get to all of them, and I have to switch gears a little bit here because I really want, and Bob, you've referred to it a number of times, and Shane, you're going to do the same thing. As sponsors, we really want to know what your company is doing about a lot of different things. And the two questions that you can answer when you talk about Reinhausen specifically are, so why this digital twin? So that's part of the digitalization question as one of them, and the other one relates to the vacuum retrofill. Doesn't that then do away for the need for DGA because there is no oil in the vacuum. So what is it that the newer type, let me say, more innovative OLTCs, what is it that you think is going to change the marketplace?
Yeah, so maybe I'll take the second one first. So I mean, there is oil in an oil type tap changer. A vacuum
Right.
tap changer does have oil in it, so it doesn't eliminate the oil. So that's why when we talk about DGA, it's still relevant to monitor DGA within a OLTC, bolt-on as an example that we provide out of the US. So from that side, I think that's that vacuum the benefit of the vacuum technology when it was launched decades ago was the ability to operate hundreds of thousands of operations without maintenance. The vacuum bottles are designed for millions of operations, so that's the beauty of the vacuum technology versus the traditional oil technology. But you still need to monitor and make sure that you have data coming in to ensure that everything is still operating in the right way, because it is one of the only items on a transformer that has moving parts. You want to make sure that that's in a good condition on a real-time basis. What was the other question, Alan?
So you answered the digital twin question, the
Yeah.
value of the digital twin.
So I mean, at the end of the day, you've got an asset that's sitting out there in the field that's operating, and it's a very expensive. It's the most expensive asset that you have in a substation is your transformer. So having the ability to bring data from multiple different sources, whether it's from the OLTC, whether it's from the bushings, whether it's from cooling, whether it's the AVR that you're utilizing to regulate the voltage on the tap changer, DGA, it gives all different sources of information. Getting that information into a single device that allows you to analyze it and provide recommendations based on condition, that's really where you get the digital twinning from, because it's looking at what the transformer should be out of the box and where is it starting to deviate from what it should be, and then what are the recommendations that we have based on those deviations to take action to remedy. So that's really the value and the point of the digital twin is you can take the perfect condition, the deviated condition, make recommendations, repair back to what should be close to perfect again. And that's why you do that.
Okay. What's going on with Reinhausen US?
So I guess I'll give you a scoop on something we're actually going to do a press release on tomorrow morning. So I'll say you get to hear it first here.
I like this. You heard it here first.
You heard it here first. So we're going to announce tomorrow another capital investment in Humboldt. So we just completed a capital investment in 2024, expanding our facility, adding a warehouse and additional office space. And I mentioned earlier about the fact that, every prediction of market growth coming out of companies like McKinsey and IEA always change year by year, probably in the factor of 50% if we look at data center load growth as one example. The demand overall for tap changers and transformers over in the US has continued to grow faster than people expected. And so even though we just made a capital investment, we now are going to make another one to expand our facility even further to meet the additional demand that we're seeing out of the marketplace. So we'll make that announcement tomorrow. We'll add another 12,000 square feet of manufacturing space in Humboldt, plus additional office space so that we can continue to meet the demand today and into the 2030s and beyond.
Excellent. That's great. You have a service center here, right? You have manufacturing here. Just talk a little bit about that.
Yeah, so we've got several different areas of service. So we've got our traditional OLTC service business, which is providing services to all of our customers who own the Reinhausen tap changers out in the marketplace. So we have service techs that go out on a regular basis. When the OLTCs do require maintenance, that they go out and do that work. The ones that are typically the ones that have the most amount of tap changes is in the steel industry, where they're regulating the arc furnaces. We've got a transformer service business that goes out and does regular transformer service work, whether it's OLTC retrofit, bushing replacements, regasketing, those type of things. And we've got service crews all around the country that do that type of work. And then we've got a small substation business out of the Mesa, Arizona area that goes out and provides full turnkey substations. So all of that continues to grow. So with more transformers being built, there's more service being provided to our customers on the OLTC side. The demand for services from third parties across the country continues to grow. And I think Shane can attest to that as well, that we're seeing a tremendous amount of demand and growth on the services side. And then there's just, you think about the substation business in Phoenix and that greater area, it's one of the fastest growing electrical markets in the country. So that continues to grow.
Excellent. So Shane, he just threw you that next one because North American Substation Services has been in the market, is recognized in the market. I know I met some of the people that were doing nuclear site servicing and repair. I mean, these were some of the best trained crew that I've ever come across. But talk a little bit about where North American Substation Services is now.
So, we were part of a company called Voltyx that we have a sister company called EPS, as well as we have one manufacturing business, small manufacturing business up in Quebec City, a company called Nomos that manufactures custom control cabinets for transformers, breakers, and LTCs, older ones in particular. We were recently acquired last year by Asplund, who's probably best known as the tree company, right? They trim trees for
the
vegetation.
vegetation guys.
I didn't, before we were purchased, honestly, I didn't know a whole lot about Asplund, but it turns out that Asplund is quite a large organization that has outlays into the utility industry beyond vegetation. Obviously, they do engineering, so substation design, distribution, transmission. They put up lines, power lines, power poles, have a whole construction wing, electrical testing. Well, I think we're unique in the sense that they did not have a transformer break or high voltage equipment service provider under their portfolio at the time. But so we were acquired last year. They're starting to really invest more and more into our organization specifically, and bringing us into the larger organization as we call it the one Asplund group, essentially. So the ultimate goal being to be able to provide turnkey service from cutting the trees down to energizing the substation, essentially, or whatnot, right?
You call it soup to nuts. You can go all the way across the whole thing. We're going to give you an opportunity because that's really good. When I asked you about North American Substation Services, you really hit the idea that they're part of a bigger picture. We interviewed, if I'm not mistaken, it was the CEO of Asplund at Distributech or somebody senior. And
Brett Asplund, is that it?
Yeah, I did not know all that. I mean, they're the vegetation guys. Now you're talking about construction, engineering. There's a lot of things that we didn't know, and that's a good fit. That's a good fit. Shane, Lance, talk a little bit about Doble. We all know what's going on. You only got about a minute left, but talk a little bit. We know what's going on in the industry. What's going on with Doble?
So Doble is constantly looking at new online and offline testing products. The Doble laboratories themselves is heavily involved in forensics. So we are now tearing down pushings, we're tearing down CTs, we're doing a variety of forensic work to help people understand what's going wrong with their equipment, or if it's a manufacturer specific issue. But one of my counterparts just texted me and told me that we now offer dynamic resistance measurement capability in the M7100s. So that would help with LTC testing as well. So they're having a meeting now to see how we're going to move forward in the future with our products and our product offerings. So that's always a constant moving part within Doble, is how to make something better and of better use to customers out there.
Hey, we all live in capital markets, and capital markets require innovation, change, and consistency in vision. I really appreciate, gentlemen, that you sharing with us. So there are a bunch of other questions that they're probably more designated to one of you. We're going to send those to you, and then we'll give the people answers. But this has been an APC Media production, a power panel on OLTCs. Thank you for joining us.
Thank you.